Section 7.5, Applications of Rational Expressions. So in this section, 7.5, we're going to look at the rational equations we dealt with in the previous section, 7.4, but now we are going to apply them, create these rational equations based off of a real-world situation. That's kind of the second half of this section. The first half also just gives you some equations that might be scientific based, and they have various multiple variables in them, and we have to solve these equations for a specific variable in the formula. Alright, our first example, we have the equation 1 over f equals 1 over p plus 1 over q. We don't know what the value of those three are, except over here we do. We are given the value of a couple of our variables. We are asked to find q if p is equal to 20 centimeters and f is equal to 10 centimeters. So we can fill in what we know from the problem. F is 10, so we have ourselves that 1 over 10, or 1/10, is equal to 1 over p, which is 20. So 1 over 20 plus 1 over q. Well, that's the one variable we don't know the value of in this problem. Okay. So there's our resulting equation, and in order to solve this, since we have fractions involved, we can get rid of those fractions on both sides of the equations by multiplying by the LCD. Okay, we learned how to handle this in the last section. So we want to multiply by the lowest common denominator, which in this case we have denominators of 10, 20, and q. Okay, so the different factors we have are, well, 10 we can get to go into 20, so as far as the numbers, 20 would be our LCD, but then we have this separate factor of a q. So our LCD is actually going to be 20q, because that would be the smallest thing that we could get to all of our other denominators to multiply into. Alright, so we're going to multiply by the LCD of 20q to clear our fractions. So we have our original equation, which is 1/10 equals 1 over 20. Leave a little bit of space, and then plus 1 over q. And now we have to come by in each case and multiply by the LCD, 20q. So each term needs to be multiplied by 20q. We learned this again last section. It's 20q times that fraction, 20q times the 1/20th, and 20q times the 1 over q. Okay. So here's where we can look diagonally and factor out, I guess kind of divide out any common factors. If it helps, we can think of all our 20q's as 20q over 1. And so remember, looking diagonally here when we're multiplying, and diagonally here when we multiply. So in their first fraction, the 20 over 10, we can reduce that fraction. 10 goes into 20 two times. 10 goes into 10 one time. So, you know, when we do this, it is going to get rid of our fractions. So the 10 should cancel out, which it does. In our next fraction, diagonally, the common factors of 20 and 20 will divide out. And then in our last multiplication, the common factor of q diagonally will divide out. So this will result in, we have 2q times 1, which will just give us a 2q. Equals, over here the 20 is canceled, but we would still have this q times 1, which would just be a q, plus the q is canceled, but the 20 times 1 gives us a 20. And if we're trying to solve for q, well, we'd want to get our q terms on the same side, so, and keep the constant term, the 20, on the other side. So let's move this q over to the left side of the equation. Since it's a positive q, we'd want to subtract q to cancel it out. So we have to subtract the q on both sides of the equation. So q minus q gets rid of it there. 2q minus 1 minus a single q gives us a single q. So we actually get to our final answer right here, q equals 20. And I guess we're dealing in centimeters and all these other variables, so 20 centimeters would be our answer. Okay. So that's actually pretty similar to what we've already looked at in 7.4. It's just we were given a problem originally that has multiple variables. We were just then given the value of those variables, or of some of those variables. So then we just find the value of what's left. Alright, next example. We have PV over T, and those are all capital letters, is going to be equal to PV over T, all lowercase letters. So the capital P, the capital V, capital T are going to be different variables than the lowercase p, v, and t. So find the value of P when T is 250, lowercase t is 325, uppercase V is 9, uppercase P is 100, lowercase v is 8. So let's just fill in what we know, what we're given in this problem. So uppercase P times V, which is 100 times 9, over capital T, which is 250. Okay. That's going to equal this lowercase kind of cursive p. We don't know that, so I have to keep it times lowercase v, which is 8, all over lowercase t, which is 325. Alright, so there's the problem now that we plugged everything in. We can go ahead and clean up a little bit, go ahead and multiply the 100 times 9, and we can write p times 8 as just 8p. So doing that, we get 900 over 250 equals 8p over 325. Okay, and now we could get rid of our denominators, get rid of our fractions by finding the lowest common denominator of 250 and 325 and multiplying by that number on both sides. Now, because these are such large numbers, that'd be kind of difficult to find the lowest common denominator. It's going to be a pretty huge number. There's another way we could solve this, because we have a fraction equaling a fraction, and that's actually a proportion. Whenever you have just a single fraction equaling another single fraction, we can handle that as a proportion, and so we can cross multiply. And that's going to probably make it a little bit easier. So when you have a fraction equaling a fraction, then we know that if we multiply along one diagonal, it has to equal whatever we get if we multiply along the other diagonal. Alright, so I guess we could take this over here. So proportion. Cross multiplying is going to be our easiest solution to fix this problem. Okay, so multiplying along one of the diagonals, 250 times the 8p. Okay, we can go ahead and multiply there. And that's going to have to equal, since these fractions are equal, that has to equal the all other diagonals product, 900 times 325. Okay. So we can go ahead and multiply. 8p times 250 is going to give us 2000p equals 900 times 325 should give you 292,500. And then we would want to divide on both sides by 2000 to get rid of our coefficient on p, get p by itself. So dividing on both sides, since it's an equation, we'll cancel out our coefficient there. And we get p is equal to, when we divide 292,500 by 2,000, we get 146.25. So that was another rational, we could call this a rational expression or a rational equation because we have fractions that have variables and other things in them. But multiplying by that lowest common denominator doesn't necessarily always give you the quickest answer. It'd be easier, I think, in this one just to know how to cross multiply. But that only works because we had a single fraction equaling another single fraction. It's not going to be the same as we look at our first example. We had a fraction equaling another fraction plus another fraction. So we couldn't use that cross multiplying there. It has to just be a single fraction equaling another single fraction. Alright. So in the two examples we just completed, both of those gave us values for all of our variables except for one. So we really just had to solve for the one variable we weren't given the value for. We're now going to look at some examples where you have to solve formulas, some equations for a specific variable where we don't know the values of the other variables. So this makes it a little bit trickier. You have to kind of treat those other variables you're not solving for as if they were just numbers, and think, how would I get rid of this if it was a number rather than a variable? So I know this can be a little more tricky, but we'll try to approach it the same way. Alright, so first things first, if we have a problem involving three different fractions, we can't do the cross multiplying because it's not just a fraction equaling fraction. We can multiply by the LCD, though, of P, Q, and R in order to clear our fractions. Okay. So we want to multiply by the LCD, which in this case, our LCD, we have a factor of a P, a Q, and an R, kind of to make them all match each other. Well, none of those are factorable, so we just kind of stick them all together. PQR is going to be our least common denominator here. So we can rewrite our problem, 3 over P, and just leave some room on either side of each fraction to multiply by our LCD. 3 over Q. Sorry, I need to leave some room there to multiply. That's going to equal 5 over R. Okay. So there's our original expression. Now we need to come through, multiply by our LCD. So PQR times that first fraction. PQR times the second fraction. And PQR times the third fraction. And in order to cancel out our fractions, which this should do, we look and see what common factor diagonally in each multiplication will cancel out. So here diagonally the p's will cancel. In our second fraction, the q's, q and the q will cancel. And in our third fraction, the r and the r will cancel. Okay. So now we just need to multiply through what's left. So we have a QR times 3. We can just write that as 3QR. Plus, we have a 3 times a P times an R. So 3PR equals, we have 5 times PQ. So 5PQ. Okay. So here's where this is kind of different than anything we've really done so far in a class like this. Well, for one thing, if we're trying to solve for Q, what we would normally do is get the Q terms on the same side in order to combine them into one single Q term somehow. So that's going to be the same. Okay. Since we're solving for Q, we need to get the terms with a Q on the same side. Alright, since we already have a 3PR on the left, the easiest way to only have to do one move, it would be to move this 3QR over onto the side with a 5PQ. So it's a positive 3QR right now. So to get rid of it, we'd want to subtract 3QR and subtract 3QR. Remembering what it is to be a like term. This has a PQ as variables. This term has a QR. They're not exactly matching, so we can't combine them. So what would happen is this would just be 3PR on the left-hand side, because this would cancel when we subtract. And then we just have 5PQ minus 3QR. We cannot combine those. However, we have to form some kind of way to turn this into a single Q term. We have to essentially get the Q's out of these, because we're not done with this problem until we get Q, a single Q by itself equals something else. That's what you're doing when you're solving an equation for a variable. You're trying to get that variable completely by itself. So in a problem like this, where we have two terms that aren't like terms, we can't combine them, but they both do have a Q in them, we can factor this. Okay? They both have a Q, so we could factor out a GCF from both of these terms. We could factor out a Q. Okay. So left-hand side, we have 3PR equals, well, if we pulled a Q out, then we would have a 5P as the first term left in the parenthesis, because that would give us Q times 5P would be 5PQ, minus, we'd be left with a 3R, because Q times minus 3R would be minus 3QR. Alright, so now factoring that Q out gets us a single Q kind of by itself there. But we need to do one more step to actually get it completely by itself on the right-hand side of this equation. And so Q in front of a parenthesis here is like saying Q times that parenthesis. So to get rid of the 5P minus 3R, we have to divide on both sides by 5P minus 3R. Okay, we can think of dividing it, because we know when you do that, that will cancel something like that out. But of course we have to do it on the other side as well. So divide by 5P minus 3R. Okay. So again, it divides it out on the right hand side. We get our Q by itself. So our answer is going to be that Q equals 3PR over 5P minus 3R. You can't start dividing out P's and R's because they have to be common factors. So you'd have to be able to factor this, or factor the top. We would need another P or an R outside of this parenthesis in order to cancel it out with something up top. And up top we would need a whole factor of a 5P minus 3R in parentheses in order to divide it out with the bottom here. So this right here, you don't really need the parentheses in the bottom. This would be your answer. Q is equal to 3PR over 5P minus 3R. Okay. Of course, these become trickier since you're not given numbers to plug into the other variables. It's a lot trickier to try to manipulate these equations then. Okay. We can now look at the next page. We have another multiple variable equation we're going to want to manipulate, kind of the way we just did that one. Okay. Let's take a look at this. We are being asked to solve the equation I equals n times e over r plus nr, and we're asked to solve it for the variable n. Okay. So first things first, we have ourselves a different kind of situation than we did on the last. And either way you approach this, you're going to kind of do the same thing either way. But I by itself we could think of as a fraction by putting it over 1, and that way we do have ourselves a proportion. Okay, we have a fraction equaling another fraction, so we can think of that as a proportion. We could cross multiply to handle this one. Okay. So if we multiply along this top left to bottom right diagonal, we're going to get that I, capital I, times R plus NR. Well, we have to be careful here because we have multiple terms, so we want to put that in parentheses. That is going to equal, multiplying the other diagonal, 1 times NE, which is just going to be NE, but just for the sake of showing that step, I'll put it there. Alright, so now we can start trying to clean up this equation. Distributing the I through is going to give us I times R is IR plus capital I times NR. It's just going to be capital I NR. That's going to equal NE. Okay. So at this point, now comes, I guess, the important move. We're trying to solve for n, so what do we need to do? Again, on the last example, when we were trying to solve for the variable, we have to get those terms on the same side. So since we're trying to solve for n, we need to get all of the n terms on the same side. Okay. Once we get them on the same side, then we can, try to combine them or factor in order to get an n, kind of a single n by itself. So, since we have two terms on the left-hand side, one of them being an n term, we want to move this over to the other side with the other n term. So, in order to get rid of a positive INR, we want to subtract an INR from that side and subtract an INR term from that side. Result here is going to be capital IR. Those will cancel. So that's going to equal NE minus capital INR. Okay. Again, because we subtracted here, so those would cancel. We can't combine these because they're not like terms. They don't have all matching variables, so there's nothing we can do to combine them at that point. So since we can't combine them and we need to get a single n out of here somehow, we need to do what we did on the last problem and factor. So we want to factor out an n. So factoring out an n, it's going to give us that IR capital on the left-hand side equals, if we pull an n out of here, we're going to be left with capital E minus, that would handle the first term, and then if we pull an n out of here, we'd be left with an IR. Alright, so that gets us the n out of it, and we just need to get that n but completely by itself on the right hand side now. And just like we did on the last one, if this really means n times that parenthesis, to get rid of what's in that parenthesis and move it to the other side, we need to divide by whatever's in the parenthesis. So E minus IR. Okay, we can divide by that here. And we can divide by that over here. E minus IR. Okay. Again, if you want to think of it as in parentheses, you can. Because we have that common factor here now when we divide by it, so that allows us to cancel that out. So now we have our answer. We solved it for n now. N is now by itself. N is equivalent to capital I, capital R, over capital E minus capital I over lowercase r. Or not over lowercase r, times lowercase r. So another crazy looking answer. Multiple variables in your answer because we're never given the value of I or R or E. So your answer is going to have variables in it, which isn't the nicest thing to have to deal with, but you're going to have to handle it. Okay. Alright. Now we actually have some word problems. So these will be a little bit better, I think. So you actually can kind of use some common sense on them. So our first problem is gives a situation. In 2005, about 15 out of every 100 Americans had no health insurance. If the total population was about 296 million, how many people had no insurance? So a couple ways to do these, but I think the easiest way, this is just a straight proportion problem. Okay? So it's like if they sampled 100 people, then during that time, back in 2005, if they sampled 100 people, about 15 out of every 100 would have no insurance. Okay? So 15 out of every 100 Americans had no insurance. Health insurance, that is. Well, and then they give us a total population. Obviously, we're going to need to incorporate that too. So the total population was about 296 million. How many people have no insurance? This is going to be a proportion problem. If the rate of 15 out of every 100 is no insurance, it's like at that same rate, how many don't have insurance out of 296? So what we can do is we can think of it this way. The people that don't have insurance, okay, the amount of people that have no insurance in our sample size out of the total people in that sample size, okay, that being the 15 out of 100, well, that has to be proportional then to how many people don't have insurance in the whole population out of just the total population. Everybody, insurance or not. Okay, so we know 3 of the 4 pieces in this proportion, and we can cross multiply to find the missing 4th piece we don't know. All right, so it's filling. We know no insurance sample size. That's 15 out of the total sample 100. Okay, so 15 people out of 100 don't have insurance. What does that kind of correlate to if there's 296 total million people total? So that's going to equal how many people without insurance. So we can put our variable there because that's what we're trying to find over the total population, which is the 296 million. So I'm just going to write 296, and we can calculate this using 296, but when we get our answer, just know that our answer is in millions. Okay. So we need to cross multiply. Okay, we have ourselves a proportion. We can cross multiply. It actually then makes it pretty simple to solve. So cross multiplying here, we give ourselves 100 times x equals 15 times 296. Okay. And then actually, we could go ahead and multiply 15 times 296, but either way, no matter what you get there, in order for us to get x by itself, we're going to end up having to divide by 100. So you might as well just do it all in one step and save yourself. Okay. So 100 times x equals 15 times 296, but to get x by itself, divide by 100. So 15 times 296 divided by 100, you should get that the amount of people that had no insurance in the total population was equals 44.4 million now. Because our answer here, remember we're looking at it in millions. Because 296 was actually how many millions of people. So 44.4 million, which would be 44,400,000. All right, so a lot of these problems, if you catch it, that it's just a straight proportion problem. It's easy setting it up like this. A lot of these will get much more difficult. Here, we're about going to look at here now. We're going to be much more difficult than that, but proportions, not too bad. Okay. Looking at our next example. We have Marissa's car uses 8 gallons of gas to travel 210 miles. If she has 5 gallons of gas in the car and needs to travel 640 miles, how many more gallons of gas does she need? Okay. So again, if possible, you're going to want to try to set up a proportion if you can. So our proportions just have to kind of have the same setup. Our two fractions in the proportion, kind of like we had over here. We had the no insurance amount over the total amount for our sample. Then we had the no insurance amount over the total for our whole population. So we did no insurance over total, no insurance over total. So if we want to try to set up a proportion in this problem, we can say put gallons over however many miles they were able to drive on that gallons equals gallons over miles. So in setting up our proportions, our proportion, both of our fractions we want to look at as gallons over the corresponding amount of miles you were able to drive with that amount of gallons of gas. Okay. So first sentence there, it took 8 gallons of gas to travel 210 miles. So our first fraction could be that 8 gallons took 210 miles. And then this is going to be equivalent or proportional to, well, here's where it gets a little trickier. She has 5 gallons of gas in the car, but she needs to travel 640 miles. Okay. So how many more gallons of gas does she need? So it's a little bit different altogether. So how many more gallons of gas does she need? So we're trying to find this amount of gallons that she will need, how many more. So we have to, that's what we want to set our variable equal to, whatever you're trying to find in a problem. So we can use G to represent the gallons needed. Okay. So 8 gallons got her 210 miles, and now she already has 5 gallons, right, from what we had up here. So 5 gallons plus how many more gallons, which we're going to find by solving for G, will get her 640 miles of driving. That's the proportion you want to set up. 8 gallons got her 210 miles. 5 gallons plus how many more will get her 640. So now we can cross multiply this proportion in order to solve for G. So cross multiplying along this bottom left to top right diagonal is going to give us 210 times, it's 2 terms, 5 plus G, so we want to write it in parentheses as the quantity, 5 plus, not Q, G. Okay. Equals, multiply the other diagonal, we have 8 times 640. Okay. In this step, actually, you could go ahead and divide by 210 right away on both sides, and then that would just leave you with a 5 plus G. So if that makes sense to you, go ahead and do that. If that doesn't make sense, then go ahead and distribute this 210. So 210 times 5 will give you 1050. 210 times G would give us 210 G. And on the right hand side, 8 times 640 gives us 5120. Okay. Trying to solve for G now is just a basic linear situation. Get the constant to the other side, so subtract 1050 from both sides. And that takes us to here, where we have, we're left with just 210G on the left-hand side. Right-hand side, 5120 minus 1050 gives us 4070. And then lastly, we can just divide by 210, and that is going to tell us how many gallons, more gallons we would need. Divide by 210, divide by 210, and we get that G equals 4070 divided by 210 gives 19.38. So a little more than 19 gallons are needed. In order to make it to 640 miles. So you think about it this way, does that answer even make sense? Since it's proportional, you can kind of common sense your way through it. If 8 gallons got her 210, then double that, 16 gallons will get her 420, and then triple that, 24 gallons will get her, what do we say, 420, then 630. So it takes 24 gallons to get 630 miles, and we have 5 plus the 19 is going to give us right around 24, a little over 24, 24.38 gallons. So that answer there should make sense, just thinking about it logically. Okay, 8 gallons get you 210 miles. 24 gallons would get you about 3 times 210 would get you 630 miles. So that should make sense. Right around 19 gallons more would be needed. All right. I think the rest of this section we will finish up in the next video. So yeah, we'll finish up 8.5 in that next video.